All right, so we're finished with 11.1, and what we found is that to solve a quadratic, right, a degree 2 polynomial equation, what we can use is the square root property. Oops. Or completing the square. All right, and the beauty about completing the square is that it works all the time. But as we saw in 11.1, it can get a little hairy, right? Especially, since you're dividing by 2 at sometimes, squaring things, adding it to both sides, the math can get a little crazy. So believe it or not, back in the day, the mathematicians understood that as well. And they were looking for a faster and an easier way to do a quadratic equation. So believe it or not, what they chose to do, and I don't know whose idea this was. I'm assuming it was the Babylonians or Assyrians, since they're the one that kind of created the completing the square process, is they actually did the completing the square process on a degree 2 polynomial with just the coefficients, the a, the b, and the c. So the completing the square process, we usually start it off, we need the lead coefficient to be 1. So we'll start this all off by dividing everything through by a. So that would give us x squared plus b over ax plus c over a equals 0, right? Because anything divided into 0 is 0. Then what we would do, right, is we would move this next piece over, right? So we would subtract CA from both sides. So that basically was the process that we use to get the incompleted square all by its lonesome. So that's the incompleted square. Then we would take the coefficient that's in front of the x, right, this piece right there, and we would divide it by 2. So since it's a fraction, let me show it this way, right? And so for fractions, we multiply by the reciprocal, and so what we get is b over 2a. And then, of course, after taking that half, right, getting the little flap that you will, what we did next is we squared it to get the area of the little square that needs to be added. And so what we're going to be adding is b squared all over 4a squared. So we come back up to here, and to complete the square, oops, let me get some of that stuff out of the way. To complete the square, we basically take our incomplete square, add the little piece that we need to add, and then we add it to the other side. Now I'm going to write it in a little bit of a different way. Oops. Because I kind of want to keep that subtraction in order. So I've added the b squared over 4a squared to both sides. Now on this side, we know from practice that it factors, right? We use this piece right there to factor it. So this factors as x plus b over 2a squared. And over here, if we add things up, right, we need basically a 4a to the top and the bottom, right? We end up getting b squared, oops, let me make that a little better, minus 4ac all over 4a squared. And for those who have probably studied what we're learning about right now, you can start to see things come into play. The next part, right, the whole idea behind completing the square was to set up the square root property. So I'll take the square root of each side. Let me go ahead and do that. Add the plus and minus. And so at this stage, what we end up with is x plus b over 2a equals plus or minus. We can break this up, right? We can take the square root of the top. Oops. B squared minus 4ac over the square root of the bottom. And of course we have x plus b over 2a equals plus or minus. We cannot break up a radical over a sum or a difference, but we can over a product. The square root of 4 is 2, The square root of a squared, right, is a, assuming everything's nice and positive. So to get this x by itself, we're now going to subtract b over 2a from both sides. And what we end up getting is that x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Whether I'm adding or subtracting, I have the same denominator, so we can bring this all together to get x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And what you have is famously known as our quadratic formula. The beauty about it is, right, like any formula, the a, the b, and the c are basically the coefficients, right, of our polynomial. And so all I need to do is plug in those values, right? So whatever value I have for a, I plug it in. Whatever value for b, I plug it in. Whatever value for c, I plug it in. And then all I got to do is some simplification. We'll go all the way back to chapter 1 where we learned our order of operations to finish it off. All right, so you don't have to remember all of this, right? That's just, I want you guys to know where it came from. What we're going to be doing throughout the rest of this video and the rest of the lesson is just using the fruits of our labor, the quadratic formula. So for my working example, right, our a is equal to 4, our b is negative 5, and our c is 9. So I'm just going to come over here to my formula. Let me rewrite it up here for us. So x, oops, let me go back to my original color. Okay, so x equals negative b plus or minus b squared minus 4ac all over 2a. So wherever I see a b, I'm going to replace it with negative 5. So there and there. Wherever I see an a, I'm going to replace it with 4. And wherever I see a c, I'm going to replace it with 9. So there you have it. So there are solutions are basically the culmination of all our work when we finish our order of operation work. So let's go ahead and do that. So x equals, well, when I take the opposite of negative 5, I get 5. Inside the parentheses here, negative 5 squared is 25. And then doing some math over here, let's see, I know 4 times 4 is 16, times the 9, what's that's 4, that's 5, that's 144. So we get minus 144 all over 8, right? 2 times 4 is 8. And then I basically have 25 take away 44, or 144, so let me do it that way. So 144 take away 20, oops. 25, sorry, messing around, carrying some stuff. That's a 9, that's a 1, that's a 1. So we get x equals 5 plus or minus the square root of 119 all over 8. All right, and so there's basically our solution. As we learned in chapter 10, right, we now know how to handle a square root of a negative. That's basically an I. So the final answer is 5 plus or minus I square root of 1 over 19 over 8. And so we have two solutions. They're both complex, right? One is 5/8 plus the square root of 119 over 8 I, or the other one is 5/8. Oops, my 8s are looking horrible. I'm getting used to writing on my iPad. Square root of 119 over 8i. So there would be our two solutions. So that beats the heck out of completing the square. You can only imagine what that process would have looked like here, right? We'd have to divide by 4, getting us a fraction there, then divide by 2, give us another fraction. It'd have been scary, all right? And now we just have a nice handy dandy formula to plug in, all right? So that took me almost 10 minutes to explain, but like I said, what we're gonna be doing throughout the rest of our lesson here in 11.2 is just using the formula, because it's the fruit of our labor, all our work, all our hard work, all right? So I'll see you in some videos coming soon as we work through and we learn about our quadratic formula. Talk to you guys later.